Then I will begin my report. My subject here, to present here is a prefabricated MVFT composite girder suitable for small span bridge. And my report will be divided into four sessions. The first is background. The second is introduction of MVFT. The third is advantages of MVFT, and the last part is findings. First, we look briefly at the background. VFT method was originally proposed in Germany in the bridge construction. As you can see in the left part graph, the original VFT girder was composed of steel girder and shear collector, a factory cast concrete. And the very quick key note to mention that the concrete slab was only made about a half of the whole concrete slab. And in the right graph, there was some detailed information, like it is proposed in 1998, and it is used in Germany and other European countries like Poland, and it can be applied to single span or continuous structure on the viaduct and frame structures, and have its many advantages such as low weight and high bearing stiffness and etc. Okay, so what we want to present today is MVFT girder. The M denotes that modified. Its origination is coming from this way. Since I was a senior engineer in the key laboratory of our bridge construction, so we are going to build a highway bridge in cold and high altitude permafrost region. The following three pictures demonstrate how devastating of the environment is. As you can see in the Tibetan and Qinghai plateau, the environment is very cold, is very harsh, and it's very cold, and it's in a high altitude plateau. So normally people will get less oxygen, and you feel dizzy, and you don't feel well in that environment. And the middle picture of it's me. Yeah, I'm in a survey of bridge maintenance. Yeah, the third picture is a highway bridge that suffers settlement because of the permafrost effect. And you can imagine if you design or construct or make a construction in such a harsh environment, and that's a very tough task. If you pour a lot of concrete, and if you made a lot of weldings inside, so we came out a solution of this prefabricated integral bridge, which is more suitable for small span bridge. And this is what we that is what our solution is. We changed this VFT girder into a whole concrete slab, and that means that we made all these girders in the factory, and also we when it comes to a 40 meter span, we make the girder concrete filled and make a hollow section. And so that is have some characteristics overall, like overall prefabrication without secondary pouring. So that means we don't have to so many labors in the high altitude and cold environment. Beams are collected by transverse weld joints cast, and the variable height of precast concrete makes the reduced dead weight, and which is a very important factor in this scenario, since in the bridge construction site in Qinghai Tibetan Plateau, it also have a lot of mega seismic events. So have a when we reduce the dead weight, and that means we can reduce risks. And we came out of still part of MVFT beam, and this is a cell collection geometry. And we made a lot of analysis of this cell collection, and we changed the radius of the comb plate, and it was found that the maximum tensile stress and stress concentration coefficient at the comb if under horizontal load increased and then decreased. The maximum tensile stress and SCF at the comb teeth under pull-out load continued. And this is the construction method we propose. The main difference, it differs with the traditional composite bridge, is that we, as you can see, we made a temporal bracket or a brace here. As you can see, as my mouth moves, and when every girder, as my moved, was standardized, and when we erect here and erect here, and this it supports the this is girder A, this is girder B, and girder A and girder B was collected with in situ concrete or weldings. And let's take in a continuous bridge with 3 by 40 meters as an example. It has a width of 19.8 meters, a steel girder web height of 1.23 meters, and it has a total of 9 girders as an example. And as you can see, the maximum stress was only 213 megapar, and the displacement was 0.16 meters. Under normal use LS state, the displacement was 0.099. And the assemble, which means the assembled prefabricated MVFT steel hybrid composite bridge structure, meets the code requirements of China and shows a great structural performance. And here we also made a concrete filled tubular arch pilot design using MVFT. And as you can see, it is suitable for mid-span bridges with aesthetic view. And the bridge deck is continuous, reducing expansion joints and maintenance costs. MVFT is economical and efficient with sufficient strength. For the same span, the CFTA MVFT bridge is lighter than the truss bridge, which means lower steel costs. And also, we propose index. We call it live loaded structural index. The objective is evaluate the application efficiency of the steel bridge under different structural schemes. And we define in this way: the LSI equals to P divide eta. and in which key denoted as span to deflection ratio, eta denoted steel weight to span ratio. And here's the table shows the LSI index, the distribution when the web height reduced from 1.3 meters to 1.1 meters. As you can see, the eta decreased from 29 to 21, and which means the LSI increases with the increase of web height. And here's a generalization of the advantages of MVFT, such as the it can ensure the quality of the beam girder, lower economic costs and lighter weight, and fast construction speed and shortened construction period, which means as we have emphasized that it is very important in the cold and high altitude bridge construction site. And better operating conditions and lower post maintenance costs. Okay, in the last if some professors or scholars are interested in our work, you can index in the website using the DUI, which is we have published 2 papers: concrete field tubular arch modified VFT bridge and its LSI analysis, and the other one is structural analysis of prefabricated steel concrete composite bridge applied in cold and high altitude permafrost region. And what's more, we are in progress in the research, and we mainly focus on the general scheme and stress analysis of connection keys for MVFT and continuous composite bridge. And we're writing a paper right now and almost finished. And the other is structural performance of prefabricated MVFT continuous girder bridge. And thank you. If you have any questions.